be discussing linear velocity. And first, we're going to look at our variables. V equals linear velocity, t equals time, w equals angular velocity, r equals radius, and theta equals our angle that we're working with. These are the three equations that you'll be using to find linear velocity. Linear velocity equals radius times angular velocity. Linear velocity equals radius times theta, or angle over time. And linear velocity equals s, or arc length, over time. That's how we'll find it. So we'll be using one or maybe multiple of these equations to find our answer. All right, on to our problem. So our problem, find the linear velocity of a record that has a radius of 8 inches and it is spinning at a speed of 4 pi radians per second. Now first, let's look at what we know, okay? So radius equals 8 inches, all right? W, or angular velocity, equals 4 pi radians per second. Okay, all right? So now we have R and W. And looking at our equations or formulas that we have to solve from, this would be the best one because it's R and W, two variables, one left over, also known as linear velocity. So, equals, dang it, V equals R W. Plug it in, plug and chug. That was a bad 8. 8 times 4 pi. It'll get you your V. 4 times pi, or 8 times 4, 32 pi equals your linear velocity. And it would transfer, not to radians, but to inches, because that is your linear measure. So inches per second. Okay, so our problem. If a circle has a diameter of 16 feet and makes 3 turns every 5 seconds, find the linear velocity in feet per minute. So we're going to have to do some converting here. So first we're going to need to find our radius because that is what our equation calls for. So 16 so to find r, we need to take the diameter divided by 2. So our diameter is 16 divided by 2, that equals 8. So our radius is 8 feet. So then we need to find our W. And our W is in this little thing, so 3 turns every second, that's going to tell us our W. We just have to find it. So we'll need to use our equation W equals theta over time. Now, our theta is in revolutions right now, 3 turns. So 3 revolutions for 1. And revolutions, put that on the bottom, 1 over every 1 revolution equals 2 pi radians. So 3 revolutions times 2 pi, that's 6 pi radians. That is how many turns. Now we need to plug it into our equation, W equals theta over time. So 6 pi over 5 is our W, but that's in radians per second. And we need to change it to radians per minute. So I'm going to do some handy dandy converting here. Put the seconds on top. Seconds. Every 60 seconds equals 1 minute. So then these cancel out. 6 times 60, that's 360. Add the pi, over 5. This is in radians per minute now, because these are the only 2 left. So radians per minute. 360 divided by 5, or you simplify that down, that's going to equal 72 pi. And that is our W. Now we need to plug it into the equation V, or our linear velocity, equals RW. So now we have our R right here, and we have our W. Plug them in. 8, gosh dang it, 8 times 72 pi V. 8 times 72 is 576. or that'd be in feet per minute, because it transfers to your the one you were using before, which is feet. So feet per minute equals